a radical review. Now you may be wondering why this is called a radical, but this thing here used to be called a square root. And you can continue to call that, but more frequently than not, we need to start calling it by something that's a little bit more general. So we call it a radical or a root. Either one will suffice. The reason being that up until now, you've had no number here. In fact, a number's been hiding, it's a 2. But that's going to change, and it could be a 3 or a 4, or heck, you could even do a 5.1. But let's just leave it that this is a value, which always asks you how many times something equals whatever's inside here. All right, so there's a few rules about radicals that you need to know moving forward. I am mainly interested in number 1, but occasionally you're going to have 3 and maybe even a 2. In Algebra 2, you'll see a lot more of all that. First of all, as to why do we begin talking about radicals? What's the big deal? Why not just wait until algebra class? Well, these are right triangles, and we need to start talking about trigonometry, which is going to relate the angle measurements to my sides. But before we do that, we need to know our sides well. So if I call this side x, you recall that from algebra class, we could say 4 squared plus x squared is equal to 10 squared. This is based on the Pythagorean theorem, and we'll talk about that more in the future. Now you should be able to square the 10, square the 4, subtract the 16 from both sides, and you'll end up with x squared needing to be 84. So this results in the fact that x needs to be positive or negative square root of 84. We'll discount the negative answer right away because we don't need a negative answer for a distance. So what is the square root of 84? Well, we could go to our calculator and approximate it, but we're going to stay in exact land. That's where mathematicians like to be. And so we have to learn to approximate it, rewrite it in simplest format. And to do that, we look for inside of the 84, is there any perfect square hiding? Lo and behold, we could change it to 4 times 21. And in this case, 4 is the only square that's hiding inside of 81, other than 1, which is a silly square to work with. But be that as it may, notice now when we do 4 times 21, we can break this up as radical 4 times radical 21. And radical 4 becomes 2, and radical 21 stays radical 21. So it's 2 radical 21. All right? Whoop. So that's why we have to deal with radicals, is we want to find exact answers for sides of triangles. So rule number 1 should be pretty easy. You've already dealt with this, in fact. In that example, you noticed we couldn't leave any square inside of a radical. So you have to take out any type of square. Now keep in mind, when you are working with cube roots or third roots, i.e., let's say the cube root of x, we can't leave cubes inside of radicals either. Especially third root radicals, as we would call them, okay? So, and we can't leave powers of 4 inside of radicals that are carried to the 4th root, all right? Rule number 2, a little bit trickier. We can't leave any ratios inside of a radical. So if you see a fraction like a over b and it's sitting inside a radical, that's got to be cleaned up. The third and final rule is that you cannot have a radical in the denominator of a fraction. These last two rules are somewhat archaic, but because they're still heavily practiced in higher mathematics, we continue to use them. That is, the reason for not doing that is old-fashioned, but it's become such a part of the math that we can't get away with it. So let's look at some examples here. The square root of 18. So clearly there is no number multiplied by itself that gives me 18. That's an exact integer, not an irrational number. So we say, can we break up 18 into two factors, which would give us, nice. Now notice 3 times 6 would be a bad choice because 3 nor 6 are perfect squares. But if I choose 9 and 2, that's advantageous because I do know the square root of 9. I don't know square root of 2, and that's okay, because my final answer will be 3 times radical 2. So, example 2. This is a case where we have a ratio inside of a radical. A lot of different strategies here. I think the best strategy is just break it up into 2 separate problems. And I would say that's kind of the general strategy for all radical problems. Break it up. So notice how we took the 18 and broke it up into 9 times 2, right? Becomes simpler. So radical 9, radical 20. Now this simplifies to 3 radical 20. We can't really leave that because that violates rule 2, or rule 3. That is, I've got a radical in my denominator. So we'll fix it. But first of all, let's clean up a radical 20. Let's take out a 4 and a 5, right? Sorry, a 4. 5 gets stuck. But I think we end up with 3 over 2 radical 5. And so this is, I'm not going to circle it because I still have a problem. Instead, this just becomes my next example. How do I get rid of a radical 5? All right, what we're going to do is I'm going to take my ratio and I'm going to multiply it by a fancy version of 1, as I like to say. Now in this case, I want my radical to somehow clean up this radical. So I take radical 5 times itself, and this is the magic. Upstairs, we get a bit of a mess. That's okay, 3 times radical 5. On the bottom, notice we have 2. I join those 2 radicals together, we get 25. But that's nothing but 5, right? So in my denominator, I have 2 times 5, which is 10. So I have now cleaned up my other problem in the previous by cleaning up that radical in the denominator. And I get 3 radical 5 over 10. All right? So best of luck as you work on these problems. We'll talk about them more in class. Again, if you get stuck, break it up into parts and deal with those parts separately and then put them all back together. Good luck.